So we have learned that a force is just causing the speed of changing the direction of any motion. For changing the direction of any motion, there requires some force. You have learned in your past two chapters. So, as you always observe in your view, an object dropped from a height. When you drop an object, it falls towards the earth. Falls towards the earth. So, this object can is simplified when the set of thinking falls towards the earth means towards down it is going. So, it is falls towards the earth. So, as you see in your surroundings, some of the things like if you see the planets, it moves around the sun only. All the planets, as you know, in the solar system, it moves around the sun. The moon goes around the earth. So our moon, it rotates around the earth. No. So seeing this all, the moon that rotates around the earth, in all these cases, there must be any force acting on that object. There must be any force acting on that object, so that object is moving around that object. Okay. So the planets and on the moon. So Isaac Newton, who could grasp that the same force is responsible for all these. So the Isaac Newton, who said that only one force is responsible for all these, and the force that is responsible for all these is the gravitational force. And about this gravitational force, the gravitational force, about this gravitational force, you are going to learn in this chapter, the gravitation. Okay. So now this is what we the starting introduction for the video. Now in this chapter we are learning about the gravitational and rotation force. So in this chapter now we shall know about gravitation and the universal law of gravitation, and we shall discuss more about the motions of an object and the effect of the gravitational force of the earth, and means how the moon moves around the earth due to this gravitational force, why, and many other things. So we shall study how the weight of the body varies from place to place, and many other things we will discuss in this chapter. So now let us start this discussion. First, gravitation. If we come to gravitation, we all know that the moon goes around the earth. An object, when you throw an object upward, it reaches some height. It reaches some height. See, if I throw here, it reaches some height. Till here it reaches. Again it comes down. Okay. And then it again falls down. So it is said that Newton was sitting under a tree. So people during that people, they said that when Newton was sitting on a tree, an apple comes and fell on his head, and the fall of the apple made Newton to start thinking that if the earth can attract an apple, can it not attract the moon, or is the force of the apple, is the force the same on both cases? It will be the force same on both cases when it attracts the apple and moon. And he also considered that the same type of force is responsible for both the cases. So only one force, the gravitational force, it is responsible for both the cases, for attraction of apple or attraction of the moon. So he argued that at each point of its orbit, so at each point of the orbit of the earth, the moon falls towards the earth. So the moon at each orbit, it comes towards the earth. Inside of a going up in a straight line. So inside going up in a straight line, it comes towards the earth. So it must be attracted by the earth, but we do not really see the moon falling towards earth. So we understand, we cannot see that the moon is falling towards earth and towards earth. We cannot say. Through our naked eyes we cannot easily say. Now let us take an example. Take a stone, tie it with a thread and start rotating in circle. So before you release the thread, it is an example only. So before you release the thread, the stone moves in a circular path with a certain speed. So with a certain speed, which speed you are trying to move, in that speed, the stone rotates in circular path. It rotates, and also it changes its direction at some points. At every point, it changes its direction. Means it will be going little bit speed, so that's why it will be going a little bit forward. Or if you make slow, it will be coming backward. So the change in direction involves change in velocity or acceleration. So change in the velocity or acceleration involves happen when you change the when there is a change in direction. So the force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. So from center the force is acting that makes this stone to turn towards the in a circular path, and this force is called the centripetal force, or for meaning is center seeking force. From center, in center it is move, the other stone it is moving, the stone from center only it is moving. So in the absence of this centripetal force, the stone flies off along a straight line, and this straight line will be tangent to the circular path. So see, if the stone is in circular path, it is rotating, not but if it is not in centripetal force, then it will go straight like this, try to this path. You can play it as a like this, you can mention. So therefore a straight line that meets the circle at one and only one point is that we call it as tangent to the circle. You may have learned in your mathematics. Now let us come to the physics example, gravitational force. So it is seen that a falling is in so the motion of the moon around the earth is due to this centripetal force. So the centripetal force means the force that causes the acceleration and keeps the body uh, moving along the circular path is acting towards the center, and this force that acting towards the center and keeps the body moving is called as centripetal force. Okay, so this is the explanation of centripetal force. Okay, you have learned, I think so. Now, so as you know, the like this, the motion of a moon around the earth is due to this centripetal force. Okay, see, centripetal force is an topic to learn now. Centripetal force. Okay. Now, the centripetal force is provided by the force of attraction of the earth. So, due to the force of attraction made by the earth, the centripetal force is made. So, if there were no much force, the moon would pursue a uniform straight line motion. So if there was no much force, this moon was not working in this centripetal force, it was going like a tangent like this. And next, if we come, it is seen that the falling of the apple is attracted towards the earth. So the apple that has fallen on the Newton. So it is seen that the falling apple is attracted towards the earth. So the falling apple that is fall on Newton's head, which does not straight fall on Newton's head. It was the apple was attracted by the force of earth, attraction force of the earth. Does the apple attract the earth? If so, we do not see the earth moving towards an apple. Why? So, what if you think like this? The question. According to the third law of motion, the apple does attract the earth. The apple attracts the earth, but according to second law of motion, for a given force, acceleration is inversely proportional to mass of the object. So for any so according to second law, for a given gravitational force acceleration is inversely proportional to the mass of the object. So the mass of an apple is negligible. So we cannot say this much on the mass of the apple. It is negligible. Some small mass of the apple is negligible, and it is small compared to the mass of the earth. So we do not see the earth moving towards the apple. So that's why the mass of the apple is very much less compared to the earth. So that's why we do not see apple moving means earth moving towards the apple. So extend the same argument for why the earth does not move towards the moon. So why the earth does not move towards the moon? It is due to this one second law of Newton. As you know, the acceleration, it is inversely proportional to the mass of the object. Due to that, the earth means the earth does not move towards the moon. So in our solar system, all the planets go around the sun. Then in solar system, you see all the planets move around the sun. You will see them. But by arguing, if you argue in the same way, we can say that there exists a force between the sun and the planet. So there is a force between the sun and the planet, by which the all these, by which the planets move around, moving around the sun. So from the above fact, Newton he concluded that not only does the earth attract an apple and the moon, but all the objects in the universe it also attract each other. So Newton he got apple, earth attracts apple, or earth attracts moon. Not only this much, in whole universe, some object or attracted by some other object, and this force of attraction that is between these objects is called the gravitational force. So the attraction happened between these two objects is we call as the gravitational force. So the object in the universe it attracts each other. So the attraction that is between these objects, that attraction we call it as the gravitational force. Now if we come to look at the universal law of gravitation, law of gravitation. So every object in the universe it attracts to other object with a force which is proportional to the product of their masses. So every object in the universe it attracts the object to other object in the universe that is having less mass, or the attract with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. When the force is along the line standing in the center of the object. Now see, take this apart. So this is two objects, circle or object. You can take. This is the radius. So they both try to attract each other. So the distance, this is the distance between them, both of them. So therefore, the formula is for this is the gravitational force between two uniform objects is directed along the line joining its their center. The line that is joining. So the formula for the x is equal to by e square. It is the formula for it. So now if let two objects A and B of the mass m and capital M and small m lies at the distance d from each other, as we see like this. Let the force of attraction between two objects, force of attraction between two objects F, that is taken as F is the force of the attraction between two objects. So just take F as force of attraction, M are capital M and small m. So they are the capital M is the and small m, they are the masses. masses. These two are the objects. Okay. So, and according to the universal law, according to this universal law of Newton, the force between two objects is directly proportional to the product of their mass. So the force between these two objects, it is directly proportional between the mass of two objects into m. This is m is big object and m is the small object. Okay, and see, and the force between the two objects is directly proportional to the squares of the distance between them. So the force, this we can also say that force between the two objects is inversely proportional. It is inversely proportional to the squares. If we take the squares of the distance, the force this will be directly proportional squares of the distance between them. So the force between two objects is inversely proportional. The force between the two objects will get inversely proportional if we take the squares of the distance between them. The square if we take between the distance, then we will get the same force only. So when Newton tried to combine these both, electrical gravitation and equation 2, he gets the formula that we got now, this one. That is F is directly proportional to m into m by d square, or we can also say F is equal to g into gravitational into m by d square. So like this, the Newton has given that formula. So I explained how the Newton has given this formula to us. Now, so G is the constant of proportionality. So here, what is G? If you ask, G it will be the here I write constant of proportionality. So G is the constant of proportionality, and you can also say that universal gravitational constant also can be as universal gravitational constant. By multiplying this crosswise, if you multiply this crosswise, you will get an formula again, that is F into crosswise. If you multiply this by this, will come here, and also G is equal to G into M into small m. This you will get when you multiply crosswise. This will come here, and this will get multiplied with each other, like this you will get. Okay. Next. So next, let us after we learned about gravitation force and universal law of gravitation. So I will tell you a little bit about Isaac Newton. Isaac Newton was born in Woolsthorpe, that is near Grantham in England, and he is generally regarded as the most original and influential theorist in the history of science. So he was born in a poor farming family, but he was not good at farming, so he was sent to study in Cambridge University in 1661, and in 1665 a plague broke out in the Cambridge, and so Newton took a year off, and it was during this year that the incident of the apple falling on him was happened in this year. This one year when Newton came out from Cambridge, the means from Cambridge when he came out, he took a year off. That time this apple falling incident, by which he found his gravitational force and universal of gravitation, this happened, and this incident prompted Newton to explore the possibility of connecting gravity with a force. This made Newton to make this gravitational force and universal of gravitation also. By this incident, he was promoted Newton to explore more possibility for connecting the gravity with force, and that kept the moon in this orbit, and by which the moon is in this orbit. So this led him to universal law of gravitation. So by this he found the universal law of gravitation, and it is remarkable, and it is very much important that many great scientists before him knew of gravity, but they were failed to explain it. So Newton formulated the well-known laws of motion, and he worked on the theories of light and color, and he designed an astronomical telescope to carry out astronomical observation, and many other things was done by Newton. So after knowing about the Newton, now it has come. So here it can be also written as or f is equal to, or means g is equal to, you can multiply this f here. Okay, so therefore g is equal to f d square by 1 into f, reciprocal to this thing here. So the SI unit of g can be obtained by substituting the units of force, distance and mass in this equation. If you substitute the value of force, distance, mass, you will get the SI unit of gravitational g. That is, you can write this is the SI unit of gravitation. So the value of g was found out by another scientist. His name is Henry Cavendish. He was from the year 1931 to 1810 by using a sensitive balance. So using sensitive balance, the accepted value, the value for g was found by Henry Cavendish. That is, the value of g is 6.673 into 10 to the power minus 7. The formula given by the Newton. Now, so we know that there exists a force of attraction between any two objects. So between any two objects, the forces exist, attraction exists. So now we have to compute the value of the force between you and your friend sitting closely, or many other examples you can also take in your daily life to make the examples of gravitation. So now the law is universal in the sense that it is applicable to all the bodies, whether the bodies are big or small, or whether they are celestiatic or terrestriatic. So inverse square. So inverse square is found by Newton. Inverse square saying that a force is inversely proportional to the square of the d, means for example that if d gets bigger by a factor of 6, then f becomes 1 by 36, means 6 times bigger times smaller. 1 by 36 times smaller, they have said 1 by 36 times smaller. It is an example. So this way you can also say if it is directly proportional to the square of d, means d square. Like this also you can say. So by using the formula they have given a question, you can also solve the question on your textbook also. The question by using the formula, that is by using this formula you can solve the question they have given. You can solve it. Okay. Now let us come to our next topic. Our next one is the importance of universal law of gravitation. So you learned what is universal law of gravitation, but you should know why it is important. So importance of universal law of gravitation is why it is important. Importance of universal law of gravitation. Universal law of gravitation. So universal law of gravitation, why it is important. So why you have to make good. So why it is very much important for us, you have to know. So it is very much important. So the universal law of gravitation is successfully explained successfully several phenomena which were believed to be unconnected. So several phenomena that are believed to be unconnected, it is very much explained by universal law of gravitation. One of them is of them are like the force that binds us to the earth, the force that binds us to the earth, that is gravitational force. It is explained by this universal law of gravitation. Next one is motion of the the motion of the moon around the earth has been explained to the moon around the earth has been explained to this universal law of gravitation. The next one is the motion of planet around the sun has been explained through this universal law of gravitation. The motion of the planet around the sun has been explained through this universal law of gravitation. The final one that is explained is the tides, the way tides due to the moon and the sun, the tide due to the moon and the sun, while the solar eclipse or lunar eclipse happen, the tides gets higher tides we see in the coastal lines. This next topic we are going to learn is free fall. So let us try to understand some meaning of free fall by performing some activity. So if you take a stone and if you throw it upward, it reaches a certain height and then it starts falling down. So we have learned that the earth attracts object towards it. So through gravitation, the earth attracts object towards it. We have learned now, okay? As you learned now about this gravitational force, why how it attracts and why it attracts towards it, we have learned. But this is due to the gravitational force we have learned. But whenever object fails to fall towards the earth under this force alone, we say that the object are in the free fall. So with same force, see, if we throw the force towards the earth, see, if I throw a pin and it falls in the same force, with same force only it comes to a height, and that force only it comes to a height, and then again with that force only it falls down. So it is there any changes in the velocity of the falling object? While falling, there is no change in the direction of the motion of object. It decides, it again falls like that only. See, it's like that only. It does not change any direction. But due to if we change, then only it's falls. But only see. Like this, see, if it comes like this, like that only it will go down, so there will be no change. So there will be any change in the velocity involves acceleration. Whenever an object falls towards the earth, an acceleration is involved, and this acceleration is due to the earth's gravitational force. The acceleration comes, and by that acceleration the object moves, is attracted by the earth, and the therefore this acceleration that the earth attracts the object, the acceleration is due to the gravitational force of the earth is for due to the gravity, and it is the gravity that is denoted by g, and the unit of g is same as the unit of acceleration, that is g is equal to m s square. So this is the unit of gravitation, okay? Now, so we know that from the second law of motion, the force is the product of the mass and acceleration. The force is equal to F is equal to ma. We have learned force is equal to mass and acceleration. We have learned. Let the mass of the stone in the activity lost acceleration throws one up in the stone to when it comes down. So let the mass of the stone in the activity that I explained, we already know that there is an acceleration involved in falling of that object. So there is an acceleration that involved, due to that the object falls down towards the earth, and that is the acceleration that involves due is due to the gravitational force, and it is denoted by g, you know. But therefore the magnitude of the gravitational force F will be equal to the product of mass and acceleration due to the gravitational force, that is. So acceleration due to F is equal to mg. If you take from equation 10.4 and 10.6, so mg is equal to g m into m by d square. This formula you learned, or you can say that g is equal to gm by d square. This formula we can make for the for the magnitude of the gravitational force will be equal to the product of the mass and acceleration with the gravitational force. That is this formula you will get, or from equation 1 and 2 here from starting we learn. From there you can take this one also, this one also. Here this m is the mass, m is the mass of small element of the mass of earth. D is the distance you learned in the starting only, it is the distance, and the object and the earth, and let an object be on or near the surface of the earth, and the distance, that is d, will be equal to, or the distance will be equal to the radius of the earth, and thus for object or near to the surface of the earth, we will make a formula mg is equal to g m into m by r square. So this is the formula we make when the object is on or near to the surface of the earth, and also we can say that g is equal to gm by d square. So this is the object, this is the formula for the object on or near to the surface of the earth. This is a formula for the object that is on or near to the surface of the earth. Now, so the earth is not a perfect square, we cannot say it is a perfect square. As the radius of the earth increases from the poles to the equator, the value of g becomes greater. So the value of the g keep on changing as the radius of the equator could change at the poles of the equator. For most calculations, we can take g to be more or less constant on or near the earth. So we can take g as constant sometimes when it is nearer, when it is on or near to the earth. But for objects far from the earth, the acceleration due to the gravitational force will be given in this equation. So now let us come to the main topic, that is to calculate the value of g. We have to calculate the value of the g, value of g. We can also say any small value of the g. You need a constant or a correct value of the g for calculating. So now we have to find the value of the g. So let us calculate the value of the g first. So to calculate the value of the g, first we have to put the value of g, that is gravitational, mass and radius. So the mass g of the earth will be, so therefore the mass g will be equal to 6.7 into 10 to the power minus 11, minus 12, minus 11, minus 2. It is the formula of g. M is equal to 6 into 10 to the power 24. So keep this value in your mind. And R is equal to 6.4 into 10 to the power 6 m. if we come to calculate formula, G is equal to Gm by R square we can take, because we are finding here G, so that's why. So D square we don't want, so 6.7 into 10 to the power minus 11 into 6 into 10 to the power 24. So the units, if you want, you can put or its values. We want the answer, so 6.4 into 10 to the power 6. So therefore when you calculate, you will get G is equal to 9.8 meter second per second. This is the value of V form meter per second. So therefore this is the value of the acceleration. The value of the acceleration due to the gravity of the earth, that is G is equal to 9.8 meter per second is the value. So this is the value of the G. So we have calculated the value of the G. We have calculated here. Okay. So after this, our next topic is motion of the object under the influence of gravitational force of the earth. So motion of the object. What is the motion of the object under the influence of gravitational force of the earth? Under the influence of the gravitational force of the earth, what is the motion of the earth? We have to find. Now let us start. So we know that an object it experiences acceleration due to free fall. It experiences an acceleration. So from equation we learn there is acceleration experienced by an object is independent of its mass. This means that all the objects, whether it's solid, big, small, should fall at the same rate. So at the same speed it should fall towards the earth. We have learned in the last topic. According to a story by Jerry Wood, so a object dropped different objects from the top of the leaning tower of Pisa, that is in Italy, to prove the same. So as G is constant near the earth, all the equation for the uniformly acceleration, all the equation of G is constant meter per second. So uniformly accelerated motion of the object becomes valid with the acceleration A replaced by G. So acceleration A that is replaced by G will get. So therefore the expression we will get for that is U is equal to V is equal to U plus 80, where S is equal to UT plus half 80 square we can take, and now V square that is equal to U square plus 2AS is the formula we will get. So where U and V are the initial and final velocities, S is the distance covered, and T is the time. So U and V are final and initial velocity, V is the distance, S is the distance, and T that is the time. So in applying this equation, we will take acceleration A to be positive when it is in the direction of velocity. If it is going in the direction of velocity, then the acceleration will be positive. That is in the direction of motion. The acceleration A will be negative when it opposes that motion. If it is not going towards the velocity, if it opposes that motion, then we will get the acceleration negative acceleration. If it is going towards the correct motion, then we will get the positive acceleration. Okay. Next, so using these formulas, what I have given, you have to solve some questions. We will know next what is the question we will get to solve in this formula. And next topic is give the questions in the description. we should come to our next topic. That will be our next topic will be the important topic in this chapter after gravitational, that is the mass. So the mass, it is a very important topic, as you all know. So we have all learned that in the previous chapter that mass of an object is measured of its area. It is a measure of its inertia. In the last chapter we have learned. So we have also learned that greater the mass, how much the mass is increased, the inertia will also be that much increase. So it remains the same whether the object is on the earth or the moon or even in the outer space. It remains same. But thus the mass of an object is constant and does not change from place to place. So thus sometimes the mass of an object is constant and does not change from its place to from one place to another place. So this is about the mass we are going to learn in this chapter mass. Next is the weight. Next one is the next topic of this chapter is that is the weight. So weight is the next topic you are going to learn. No, come on. Let us come to the next topic, that is weight. So we know that Earth attracts every object with a certain force, and this force that depends on the mass m of the object and the acceleration due to the gravitational g. And the weight of an object is the force with which it is attracted towards the earth. So the weight is the force that which um, by which the object it is attracted towards the earth, whether it may be moon or anything, and that we can say through the formula F is equal to force is equal to mass into acceleration. By this formula we can say, and also we can say that as F is equal to m into g. Also we can say that is gravitational. G means gravity, by the acceleration due to gravity. So the force of attraction of the earth on an object is known as the weight of the object. So the force of attraction of the earth, the force of attraction is the force of attraction of an object is the force of attraction of an object is known as the weight of the object. The weight of the object, the force of attraction of the object is known as the weight of the object. The force of attraction of the object is known as the weight of the object. Now, SI unit will be unit of weight is the same as the SI unit of the force. So that is the Newton. Newton is the SI unit. SI unit will be Newton. In this, the SI unit will be Newton. Capital N. Okay. And the weight is a force acting vertical downward, and it has both. So the weight, it is a force acting to a vertical downward, and it has both. It has both the magnitude and the direction. Both it has. So now we have learned that the value of g is constant at the given place. So at a place the value of the g is constant, we have learned. So therefore the weight of an object is directly proportional to the mass. So the weight of the object is directly proportional to the mass. The weight of the object, that is W, is directly proportional to the mass of the object. So it is due to the reason that at a given place, it is due to the reason that in a given place we can use the weight of an object as a measure of its mass. So at a given place you can use as the weight of the object as a measure of its mass. The mass of an object remains same everywhere. So in everywhere the mass of an object will be same, but that is on the earth and on any planet, whereas its weight depends on its location, because g depends on the location. So because g, it is depends on the location or where it is, how it is the place, whether the weight an object in moon, the weight of an object on the moon, the weight of an object if you go to see, it will be. We have learned that weight of an object on the moon is the force with which the earth attracts the object. So the weight of the object on the moon is the force by which the earth tries to attract the object. So in the same way, the weight of an object on the moon is the force with which the moon attracts that object. So the weight is same force of the moon by which the moon attracts other object, and the mass of the moon is less than the mass of the earth. So as you know, the mass of the moon is very much less compared to the mass of the earth. So due to this, the moon exerts lesser force of attraction on objects. So due to this, the moon exerts lesser force of attraction towards any other the object. Now if we go and see, so let the mass of the object be m. So let us take the mass of the object be m, means mass of the object as m, and let its weight of the moon be w. So w is the weight of the moon, and let the mass of the moon be m and its radius be r. So the radius will be r. Let us take radius as r, and mass of the moon be as m. So by using these, we will make the universal law. By applying universal law of gravitation, we will get as W is equal to G, that is m is the small masses, m into m by r square, we can say. So let the weight of the same object on the earth be We. This is m. Here if you take the weight of the mass, but here it is, if we take same to the earth, we will take as We. This is the earth, we are denoting it as E, and the mass of the earth is m, and r, the mass will be m, and the radius of the earth will be r. Radius of the earth will become r. So if we see, if you want information, is small information, that is earth mass will be 5.98 into 10 to the power 24 is the mass, and radius is 6.37 into 10 to the power 6, and moon's its mass is 7.36 into 10 to the power 22, and 1.74 into 10 to the power 6, it is the radius. So this is the r, this is the m mass. So by taking this value only, if you equate, that is this formula, if you take W moon is equal to G m into m by r square. So weight of mass is equal to mass into m. If you take, so weight of moon is G into G, you don't know, but you know the mass, so that way 7.36 into 10 to the power 22 is the mass, into small m you don't know, by this is the mass of the moon, by 1.74 into 10 to the power 6, it is the r square, radius, s square is to take. Okay, so therefore weight of moon, that will be equal to 2.431 into 10 to the power 10 into G into m you will get, and if you take weight of the earth, it will be 1.474 into 10 to the power 11 G into m. So if you try to divide both, that is weight of mass and weight of earth, you will get, that is 2.431 into 10 to the power 10 by 1.474 into 10 to the power 11. If you try, you will get weight of mass and weight of earth as, that is 0.165, that is equal to 1 by 6. So therefore weight of the object in the moon, this is the weight of the object in the moon, is 1. Weight of the object in moon, I can take, this is is weight of the object in earth. Okay, weight of the object in earth. So therefore the weight of the object on the moon is equal to 1 by 6 into the weight of the earth. Like this also you can say. So you can say it as like this. So the weight of the weight of the object in moon, weight of the object on the moon is equal to 1 by 6 into its weight of the earth, into its weight of the earth. And like this also you can write it. Okay, next is the next topic is we are going to know is the next topic thrust and pressure. Next topic. Have you ever wondered why a camel can run in a desert? If you know or why an army tank weighing more than a thousand ton rest upon a continuous chain? How it move army tank in a continuous chain? Or why a truck or a motor bus has much wider tires while cutting tools have sharp edges? In order to address these questions, we have to first understand the phenomena that is involved here. So it helps to introduce us a concept, to know about the concept of the net force in a particular direction. So a net force that is applied, if you come to net force in a particular direction, that also you can say as thrust, and the force per unit area, the pressure, the force the force per unit area is the pressure. It is the pressure. So this is the for the thrust and pressure acting on both it is concerned. So let us try to understand the meanings of thrust and pressure by taking some of the examples. Like you wish to fix a poster on a bulletin board. On a bulletin board you are trying to fix a poster. So to do this task you will have a press drawing pins with your thumb. In your thumb you will have drawing pins. So you apply a force on the surface area of the head of the pin, and this force is directly perpendicular to the surface area of the board. So this force acts on a similar area at the tip of the pin, and thus the pin goes inside and the poster is being put on the wall. Similarly, let us take another example. You stand on loose sand. On loose sand you are standing. Your feet go deep into the sand. Your feet go deep into the sand. Now lie down on the sand. You will find that your body will not go that deep in the sand. Both cases, the force exerted on the sand is the weight of your body. So the force that you have exerted on the sand, it is because due to your leg on the sand, due to that the weight of the body, due to your weight of the body, the leg goes inside. These are the two examples for this thrust and thrust and pressure. And next you have learned that weight is the force acting vertically downward. So weight is the force acting vertically downward. Here the force is acting perpendicular to the surface of the sand. So here the force it is acting very much perpendicular to the surface of the sand. The force acting on an object it is very much perpendicular to the surface is called the force that is acting. Now if we come to correct example of thrust, the force acting on the object that is perpendicular to the surface is called to the surface perpendicular to the surface that is called as thrust. Okay, so the force acting on the object that is perpendicular to the surface, that force is called as thrust. This is the correct example of thrust. Now let us come to our next concept, that is that when you stand on the loose sand, the second example that I have given here, the force that is the weight of your body is acting on the area equal to the area of your feet. So when you lie down, the same force acts on an area equal to the contact area of your whole body, which is larger than the area of your feet. So thus the effect of the force of the same magnitude on different areas are different. So therefore in the above case the thrust is the same. So here thrust remains same in the second case, but effects are different. There will be different effects. Therefore the effects of thrust depends on the area on which it acts. So the effect of thrust on sand is large while the standing than while lying. So thrust on unit area is called pressure. The thrust on unit area is called pressure. So therefore the pressure it will be equal to thrust by area. Pressure is equal to thrust by area. Is the formula. Substituting the SI unit of thrust and area in equation 10.20, we get the SI unit of pressure as and also the SI unit of pressure is called also Pascal, denoted as P of intensity. Sorry, it is not that. Or P of so they have given some of the questions. So I want to lost. So thus the same force acting on a smaller area exists a large pressure and a smaller pressure on a large area. This is the reason why a nail has a pointed up, knives have sharp edges, and buildings have wide foundations. So why this is there? They have said. Now next one is pressure in fluids. How pressure acts in fluids is our next topic. That is pressure in fluids. All liquids and gases, they all are fluids. A solid exerts pressure on a surface due to its weight. A solid exerts a pressure on the surface. Similarly, fluid have some weight, and they also exert some pressure on the base and walls of the container in which they are enclosed. On the walls of that, they will exert some of the pressure. And pressure exerted in any confined mass of fluid is transmitted undiminished in all directions. So the pressure in that container, it will be going in any direction. you cannot say it is going in this direction only. In all directions it may be going. So therefore pressure in the fluid we cannot say it is going in one direction. Okay. Next after this, that is buoyancy. So buoyancy is, have you ever had a swim in a pool or felt lighter? You have sometimes felt lighter or swimming pool where you feel light when you are swimming in the pool. Have you ever drawn water from a well and felt that the bucket of water is heavier when it is out of the water? Or have you ever wondered why a ship made of iron and steel does not sink in the seawater, but while the same amount of iron and steel in the form of sheet would sink? These questions there may be in your mind. By taking this buoyancy in consider, let us understand meaning by this. So, the force due to the gravitational attraction of the earth acts on the bottle in the downward direction. So the bottle is pulled downward, so that's why the bottle it is goes downward, but the water exerted an upward force on the bottle. So the water it gives an upward force on the bottle, and thus the bottle is pushed upward. So that's why the bottle comes upward. If you take an example of bottle sinking or you think of bottle in the water, so we have learned that weight of an object is the force due to the gravitational attraction of the earth. So the weight of the object is due to the force that is due to the gravitational attraction of the earth. When the bottle is immersed, when the bottle is sunk, the upward force exerted by the upward force that is exerted by the water on the bottle is greater than the weight of the bottle. Therefore, it rises up when released. So when you really leave your hand, the bottle comes up because due to the force of the water, that water pushes the bottle upward. So therefore, the bottle comes up in when you try to keep the bottle inside using water. So to keep the bottle completely immersed, the upward force on the bottle due to the water must be balanced. So the upward force in the bottle, you want to put in water. So that time it will be the force will balance. When you put the water in the bottle and then you keep in water, if you see sometimes it will be sink. But when you try to keep the empty bottle, try to put empty bottle inside the water, it will be sink. Means it will float, not sink. Okay. So this can be achieved by the external applied force acting downward. So this force must be at least by equal to the difference between the upward force and the weight of the bottle. The upward force exerted by the water on the bottle is known as the upthrust. So the upthrust or backward force means the upward force. Means buoyancy means the upward force. It is the upward force exerted by the water. The force that is upward force that is exerted by the water on the bottle, the upward force that is exerted by the water on the bottle is known as upthrust. It is known as the upthrust, or also you can see it as buoyancy. Okay, this is the explanation of buoyancy. So you may get another question: why objects float or sink when placed on the surface of the water? So why objects float or sink when placed on the surface of the water? So if you take a nail, the nail sinks, but the force due to the gravitational attraction of the earth on the iron nail pulls it downward. So the force that is due to the gravitational force, the iron nail has been pulled downward. So there is an upthrust of water on the nail. So there is an upthrust of water on the nail that is pulling it downward, which pushes it means with the upthrust that is of water that makes that nail come out, means upward. But the downward force acting on the nail is greater than the upthrust of the water on the nail. So the downward force it is that is acting on the nail, it is very much greater than the upthrust of the water on the nail. So therefore it goes on sink. It does not come up, means it goes on sink. Why nail sinks I am explaining. Okay, so the cork, if you take an example of cork, it floats while the nail sinks. So the cork, it is a cork, it floats, but the nail it keeps sinking. This happens because of the difference in the densities. There will be a difference in the density in the weight of the cork and nail. So as the density of the cork is less than the density of the water, this means that the upthrust of the water on the cork is so there is one extra concept left, that is the relative density. So let us come to the final concept, which is the relative density. So as you all know, the density of a substance is defined as the mass of the unit volume. The volume of the density is kilogram per meter cubic, and the density of a given substance under specified conditions remains the same. So therefore the density of the substance is one of its characteristic properties. So it is different for different substances. The density is different for different substances. For example, if the density of the gold is 19,300 kg meter kilogram per meter cube, while that of the water is 1000 kilogram per meter cube. So the density of a given sample of a substance can help us to determine whether it is pure or not. To determine the purity, it helps us. So it is often convenient to express density of a substance in comparison with that of water. So the relative density of a substance is the ratio of its density to density of that of water. So for formula of relative density is relative density, it is equal to density of the substance. What is the density of a substance by density of water? What is the density of the substance given by density of water? This is the formula. So this is the formula you have to use to find the answer for relative density. So these are the final concept, that is relative density. So before you end of the chapter, if you want to see the notes, learn from starting the gravitational force. What is gravitational force? We have learned centrifugal force. We have learned from starting from using centrifugal force, gravitational force, universal of gravitation, and what is its importance we have learned, and mass, weight of weight we have learned, weight of gravitational weight, and many other concepts we have learned in this chapter till now. So okay friends, it was your chapter the gravitation. So if any more questions you have further, till then take care, have a nice day, bye my dear friends.